Picture this. It's 1976. A Soviet MiG-25, the most feared interceptor jet on the planet, locks onto an unidentified aircraft over the Middle East. The pilot gets the signal. He fires a missile, and the target just disappears. Not because it was hit, not because it was destroyed, because it was already gone. The aircraft it was chasing was flying at 85,000 feet, nearly 3 times the altitude of a commercial plane. It was moving at Mach 3.2. That's over 2,000 miles per hour. The missile didn't stand a chance. Nothing did. The plane that outran that missile wasn't built last year. It wasn't built in the 1990s, or even the 1980s. It was designed in the late 1950s, and to this day, more than 60 years later, no aircraft in the history of human flight has ever officially gone faster. This is the story of the SR-71 Blackbird, a machine so far ahead of its time that the engineers who built it did UNT fully understand why it worked. A weapon so classified that the pilots who flew it were UNT allowed to tell their own wives where they were going. A plane that, even today, makes aerospace engineers shake their heads and say, how did they build that then? Let's go back to 1954. The Cold War is at a fever pitch. The United States has a massive, terrifying problem. They have no idea what the Soviet Union is building, no idea how many nuclear missiles they have, and no idea where they're pointed. Spy satellites don't exist yet. Regular aircraft get shot down. The U-2 spy plane was the best America had, but it was only a matter of time before the Soviets figured out how to kill it. And in 1960, they did exactly that, when they shot down France's Gary Powers, triggering one of the most dangerous diplomatic crises of the Cold War. The CIA needed something better, something untouchable, so they went to a man named Kelly Johnson. Kelly Johnson was not a normal engineer. He was the kind of person who solved problems that other people hadn't even named yet. He ran a secret division inside Lockheed called the Skunk Works, a black site inside a black site, where the rules of conventional aviation simply didn't apply. The government came to him with an impossible request. Build us a plane that flies so high and so fast that nothing on Earth can shoot it down. And here's the part that should stop you cold. Kelly Johnson said yes. The moment you decide to build an aircraft that flies at Mach 3, you run into a problem that most people never think about: heat. At those speeds, the friction of the air against the fuselage generates temperatures exceeding 600 degrees Fahrenheit on the surface of the aircraft. Aluminum, the material every plane in the world was built from, melts at around 1,200 degrees and weakens catastrophically long before that. You can't build a Mach 3 plane out of aluminum. The plane would tear itself apart before it ever reached the target. So Kelly Johnson made a decision that, at the time, seemed absolutely insane. He built it out of titanium. Now, here's where it gets almost unbelievable. In the late 1950s, the United States didn't have nearly enough titanium to build this aircraft. There was only one place on Earth with the quantities they needed: the Soviet Union. So the CIA, through a network of front companies and shell corporations so complex it reads like a spy novel, secretly bought the titanium from the Soviets to build the plane designed to spy on the Soviets. They didn't know what they were selling, and the Americans weren't telling. But titanium brought its own nightmare. It's extraordinarily difficult to machine. Early tools kept breaking. The metal behaved in ways engineers had never seen before. Initial test panels kept failing until someone realized that the cutting tools were contaminated with chlorine from the tap water used to clean them. Titanium and chlorine react. Every single process had to be rebuilt from scratch. And then there was the heat expansion problem. At operating temperatures, the SR-71's body would expand by several inches in flight. The titanium panels were designed with deliberate gaps between them, which meant on the ground, the plane leaked fuel. Every SR-71 that ever flew sat in a puddle on the tarmac before takeoff, dripping JP-7 fuel like a faucet that wouldn't close. The pilots didn't blink. They'd take off, climb to altitude, let the airframe heat up and seal itself, then refuel midair. That was just another Tuesday. Flying the SR-71 wasn't a job. It was something closer to being launched into space. The aircraft cruised at altitudes so high that the pilots required full pressure suits, the same kind worn by astronauts. If the cockpit depressurized at 85,000 feet, the blood in a human body would begin to boil within seconds. The pilots weren't just aviators. They were astronauts who happened to be pointing sideways instead of up. The cockpit itself reached temperatures of 300 degrees Fahrenheit on the exterior. Inside, the pilots sat in air-conditioned suits while the world around them cooked, and they weren't allowed to talk about it. Not to their friends, not to their families. The SR-71 program was so classified that pilots were instructed to lie. If someone asked where you were going, you were on a training flight. If someone asked why you were tired, you'd just had a long week. Brian Schul, one of the most decorated SR-71 pilots, once described a moment during a routine mission over Libya when Libyan air defense lit up their radar and fired surface-to-air missiles at him. His response? He pushed the throttles forward. His reconnaissance systems operator radioed him a speed check. They were traveling at Mach 3.5. The missiles were falling behind like they were thrown from a moving car. Schul later wrote that in that moment, he felt completely calm. Because he knew the most important thing about the SR-71. Nothing in the world was fast enough to catch it. In its entire operational career, not a single SR-71 was ever shot down. Over 1,000 missiles were fired at it. Every single one missed. Here's what modern engineers can't get over. The SR-71 used inlet cones, called spikes, in its engines that automatically adjusted position during flight to manage the shockwaves created at supersonic speeds. This system had to work in real time, adjusting thousands of times per second to prevent what S called an unscared, a catastrophic disruption in airflow that could violently yaw the aircraft and nearly kill the pilot. This was analog computing. This was mechanical feedback systems built in the 1950s, and it worked so well that modern engineers, even with full computer modeling and fluid dynamics software, say they would be challenged to improve on the fundamental design. The shape of the aircraft itself was groundbreaking. The Blackbird's body was designed to generate lift. The fuselage wasn't just a container for the crew, it was part of the wing. This concept, called a lifting body, is now standard in modern aircraft and spacecraft design. The SR-71 was doing it 60 years ago. Even the paint was revolutionary. The black coating on the aircraft wasn't just for aesthetics or stealth. It was specifically formulated to radiate heat away from the airframe, reducing internal temperatures by nearly 50 degrees. The color black wasn't a style choice. It was pure engineering. The SR-71 Blackbird was officially retired in 1998. The Air Force said it was too expensive to operate, too specialized. The era of satellites had arrived. But here's the thing that lingers. In 1998, when they flew the last one to its museum, it set a coast-to-coast speed record on the way there. New York to Los Angeles in 68 minutes. It retired faster than any plane alive could catch it. There's a philosophy in engineering that says truly great design feels inevitable. That when you see it, you think of course. It had to be this way. The SR-71 is the opposite of that. When you study it, when you really understand what it was doing and when it was built, the only feeling you're left with is disbelief. Not of course it had to be this way, but how on earth did anyone know to build this then? Some questions in history don't have clean answers. Some machines exist slightly outside the rules of their time. The Blackbird was one of them. Thanks for watching. If you enjoyed this journey into one of history's most incredible machines, hit that subscribe button for more stories like this one. See you next time.